Imagine you are sending a 100 MB file to your friend, but here's the question. Can the internet send that entire file as one giant piece? The answer is no. Instead, the transport layer breaks into smaller chunks, sends them across the network, and then magically reveals everything at the destination. How does it know which piece comes first, which comes last, and what happens if some pieces go missing? In this video, you will learn the fascinating process of segmentation and reassembly in the transport layer. Imagine you are sending a large 10 MB file to a friend over the internet. Do you think that entire file travels through the network as one giant piece? Not at all. Transport layer first breaks the file into many smaller pieces called segments. This process is known as segmentation. Why do we need this? Because networks have limits on how much data can be transmitted at one time. Sending smaller pieces make communication more efficient, improve error handling, and helps the network use its bandwidth effectively. For an example, a 10 MB file might be divided into 1000 smaller segments, each containing only 10 KB of data. Once these segments are created, they are sent across the network one by one. But what happens when they reach the destination? This is where reassembly comes in. The receiving device collects all the incoming segments and combines them back into the original file. To make sure every segment is placed in the correct order, the transport layer assigns a sequence number to each segment before transmission. The receiver uses this sequence number to reconstruct the original data in the correct order. That's how segmentation and reassembly work in the transport layer, breaking large data into smaller units for transmission and rebuilding it accurately at the destination. To understand segmentation and reassembly better, let's use a real-life scenario. Imagine Iron Man needs to send a highly important mission file to Spider-Man, but the file is too large to be sent in one go. So Iron Man breaks the file into multiple smaller parts before sending it. Each part is sent separately through different communication channels. This represents segmentation, breaking large data into smaller manageable pieces before transmission. Now on the Spider-Man side, things are not always perfectly organized. The parts may arrive in different order. Some may come quickly, while others may be delayed. But Spider-Man has a system. He doesn't just open the files randomly. Each part has a sequence level, so he knows exactly how to arrange them. Using this sequence number, he put all the parts back together in the correct order and reconstruct the original mission file. This represents reassembly, collecting all segments and rebuilding the original data accurately at the destination. Even if the delivery order is mixed or delayed, the final output remains perfect and complete. That's exactly how the transport layer handles data using segmentation and reassembly. Now let's visualize segmentation and reassembly in Wireshark. To set up this lab, first of all I will download Wireshark. Wireshark is a free and open source network protocol analyzer used to capture, inspect, and troubleshoot network traffic in real time. You can install Wireshark in Linux as well as in Windows. To install Wireshark, first update your Linux machine. Open a terminal and type the following command: sudo apt update. Once the update is complete, install Wireshark by typing the following command: sudo apt install wireshark-y. I have already installed Wireshark on my Linux machine, so I will move directly to the demonstration. Now let's create a file large enough to demonstrate TCP segmentation. Type the following command on the screen. As you can see, the file is much larger than a single segment can carry. TCP will automatically divide it into multiple segments before transmission. Next, start a local web server by typing python 3-m http.server 8000. Leave this terminal running because it is acting as our server. Now open a new terminal and launch Wireshark by typing sudo wireshark. Select the loopback interface because both the client and server are running on the same machine. Now start packet capture. Next, open a browser and visit http:// 127.0.0.1:8000. Or download the file directly from the terminal by typing wget http :/127.0.0.1:8000/demo.txt. Once the download is complete, stop the Wireshark capture. To view only the TCP segments carrying data, type the following display filter: TCP.len >0. This removes pure acknowledgement packets and display only the TCP segments containing payload data. Notice that the file transfer appears as many separate TCP packets rather than a single packet. This is TCP segmentation in action. To visualize reassembly, select any packet belonging to the file transfer, then right-click and then choose Follow TCP Stream. Wireshark reconstruct all the individual TCP segments and display the complete data stream as a single continuous conversation. Although the file traveled across the network as many smaller TCP segments, the receiving side reassembled those segments into the original file. This process is known as TCP reassembly. In this way, we can clearly visualize both segmentation and reassembly using Wireshark. And that's all for this video on segmentation and reassembly in the transport layer. We learned how large data is broken into smaller segments for transmission, and how those segments are reassembled at the destination to recreate the original data. We also visualized this entire process using Wireshark. If you haven't watched the previous video in this series, make sure to check it out. And if you are learning the TCP/IP model from the beginning, be sure to follow the complete TCP/IP model playlist to get the full pictures of how data travels across the network. In the next video, we will explore port numbers and learn how the transport layer delivers data to the correct application on the device. Thanks for watching, and I will see you in the next video.